Methodology for risk classification and analysis. In this video, we will cover the methodology that the Inter-American Development Bank uses to classify and assess disaster and climate change risk in infrastructure projects throughout the different stages of the project cycle. We will explain the steps required to incorporate disaster risk assessment through a comprehensive framework in a gradual and scalable manner, complementing project design, execution, and operation. So what is the methodology proposed by the IDB? The methodology comes from the IDB's Environmental and Social Policy Framework, which establishes the requirement to identify and reduce risks in projects that are exposed to natural hazards or that may worsen or generate new risk conditions in the different stages of the project cycle. The methodology that the IDB proposes suggests 3 phases for incorporating risk assessment into the evaluation of infrastructure projects. Phase 1. The Screening and Classification Phase. In this phase, we quickly and broadly identify whether the infrastructure project is exposed to hazards because of its location, whether it is vulnerable to such hazards, and whether the infrastructure is considered critical to assign a disaster and climate change risk classification to the project. This phase should be carried out as early as possible during project identification. This classification is done in 2 steps. First, we will classify the project into one of 3 preliminary categories: low, moderate, or high risk, based on exposure to geophysical or climatological hazards. We then carry out the second step to complement this preliminary analysis and obtain a more comprehensive risk classification. We do so by analyzing the project from 2 perspectives: criticality and vulnerability. Criticality refers to the degree of significance that an infrastructure or system holds due to the type and scale of services or functionality it provides. On the other hand, vulnerability refers to how susceptible an entity is to being harmed or damaged. In the case of assets, systems, and people, their intrinsic, internal, individual, and combined characteristics make them prone or resistant to damage. With this information on criticality and vulnerability, we will review our preliminary category that was based on hazard exposure and assign a risk classification to the project. This classification is fundamental to the rest of the methodology, since it's the starting point from which we will define the required disaster and climate change risk assessment. If the project is classified as low risk, there is no need to continue with the following steps. If a project is classified as moderate or high risk, we should move on to Phase 2. Phase 2, or the qualitative analysis phase. In this phase, we perform a qualitative risk analysis of the project. This phase should be carried out during project preparation as we discover more project details. It consists of 2 steps. First, gather relevant data regarding past phenomena, existing risk studies in the area, and any specific vulnerabilities that the project may have. This information will be used to make a diagnosis or a narrative that combines all existing information and establishes knowledge gaps. The process for moderate risk projects may end at this point if the narrative concludes that the risk level is not too significant or if existing risk management measures are sufficient. The second step is based on this diagnosis and consists of qualitative risk analysis at the project level. One of the ways to approach a qualitative analysis is to assess all the ways in which a project might fail as a consequence of the occurrence of a natural event, analyzing the causes of each failure and consequences for both the structure and the surrounding environment and communities. This type of assessment is most successful with the support of experts, technicians, and other stakeholders with knowledge about the project and the system under study. Using this analysis, we will be able to define specific measures to manage identified risks, which can be included in the project's design, implementation, and operation. We call this a disaster risk management plan. The qualitative analysis also enables us to identify aspects or scenarios for which detailed quantitative analyses will be required. The following summarized analyses of a road failure mode provides an example of the results of this phase through a failure mode identification workshop. The process for high-risk projects may end at this point if this fourth step concludes that the identified uncertainties are acceptable and can be managed with the proposed measures. Otherwise, we move on to the next phase of the analysis. Phase 3, or quantitative analysis phase. This phase can be carried out during project preparation or, in some cases, up to the beginning of the operation stage because it requires more detailed information, such as the preliminary design of the work in question. This phase consists of a single step and applies to projects that are classified as moderate or high risk, for which information gathered during the previous qualitative analysis is deemed insufficient to accurately determine its risk level. This phase uses advanced risk calculation techniques and includes climate change scenarios for significant hazards to determine the impact of these events on assets and the local population. This is an example of a hypothetical diagram or a risk calculation model and the corresponding quantitative analysis of the measures proposed to reduce risk. This set of measures is called a disaster risk management plan. The IDB's methodology is applied during project preparation and operation in sectors financed by the bank with the purpose of: first, helping project teams comply with disaster risk management policies. Second, supporting the implementation of resilience initiatives. And third, promoting good practices for project teams.